Cycloalkanes. Cycloalkanes are going to have rings in them or circles. So anytime you have to have at least 3 carbons to make a ring, but you can have a ring of 3 carbons or 4 or 5 or 6. That's called a cycloalkane. These are alkanes. They only have single bonds, but they're cyclo because they don't have an end. Okay? So cyclohexane has 6 carbons. Hexane would look like this. 1, 2, 3, 4, 5, 6. In cyclohexane, the one on the end has come around and bonded to the one over here. So these are the line angles, and we look at each of the points here. 1, 2, 3, 4, 5, 6. Cyclohexane looks like a hexagon. Cyclopentane looks like a pentagon. Cyclobutane looks like a butagon. Oh, no, wait, it looks like a square. And cyclopropane is a triangle. Those little guys, they've got those funny names. These are ball and stick models, especially when you get up here to cyclohexane. That gets really kind of hard to look at. We usually use the line angles for the cycloalkanes because it's just so much easier to see what's going on. Yes?
Are these still considered acyclic, or?
These are not acyclic. These are cyclic. Yeah. So earlier we were talking about the acyclic alkanes, and those were a long chain. Here is where the ends of the chain have come together. So that's a good question. So the general formula here is going to be CnH2n. For the straight chain alkanes, the acyclic ones, it was CnH2n plus 2. But in order for this to circle up, you have to lose a hydrogen off of each end. And so when we look at, well, let's look at this guy because he's simpler. This carbon has 2 hydrogens. That carbon has 2 hydrogens. This carbon has 2 hydrogens. Every carbon in that cycle has two hydrogens on it. And each of these carbons is going to be primary, secondary, tertiary, or quaternary. Primary means it's attached to one other carbon. How many carbons is this guy attached to? 2. It's attached to this one and to that one. So in a cycloalkane, all the carbons are secondary unless you have substituents. But in these just plain old unsubstituted cyclohexanes, they're all going to be secondary. And the names of them, we count up the number of carbons in that ring. So cyclohexane has 6. 6 carbons is hexane. It's in a circle, and so we just put the prefix cyclo in front of it. So let's practice generating condensed structural formulas from line angle structural formulas. This is exercise 1.6. Okay, so here's A. And here's B. Those are pretty sloppy, sorry. So they want a condensed structural formula. So that's like the CH2, CH3 kind of things. I would usually start with the ring. One way to do it is just to put the carbons in there and then put the hydrogens on there. So there's my 5 carbons in that pentagon. The one at the top is secondary. It's going to have two hydrogens. This one over here has two. This one has two, and that one has two. Come on. But this guy, pointer, but this guy is a little sloppy. That guy is tertiary, right? It's bonded to 1, 2, 3. So he only has one hydrogen. So this has one hydrogen. So I'm just going to draw the lines in here. Now what you may need to do, I'm trying to avoid doing this, I have a little more experience. What you may need to do is, you know, your first writing of this may be a mess, okay? You start out and you're scribbling in and maybe erasing and squeezing things in, figuring out how many hydrogens and where they are, and then recopy it. Okay, that's often how it has to go. And so then that's the pentagon there, and then this is going to be going up to another carbon for that corner at the top there. That's a secondary carbon, so it's going to have two hydrogens. And then going down here, that guy on the end is a primary, so he needs 3 hydrogens. There's different ways to think of how to do these. Any questions about that one? Let's do this guy over here. I have to write small, make room for him. So there's 6 carbons. 1, 2, 3, 4, 5, 6. The one at the top is secondary, so that's going to be CH